Welcome back. In this video, I'm going to talk about sort of second video. I'm going to talk about how programming languages work. And before we really talk about programming languages, we need to understand what we're trying to interact with a little bit better. And I know we talked about software and hardware in the last video, but now let's talk about kind of the history of developers and why they were created, or developers of computers. Uh, Developers were created to work with computers eventually. Um, but you can look back, and computers themselves come back. You can find some hints of them being spoken about as early as 1613. Now, it wasn't the computer that we know today. Computing was just an occupation. It was a job that people did. Often there were calculations, researchers had wanted to do involving the moon and planets and stars and how quickly they rotated and what things are going to look like in 5 days, 5 years, 50 years, in the future. And so they'd have these humans who have these very explicit mathematical calculations that they would sort of do over and over and over and kind of like carry numbers forward over and over again for hundreds of years until this man named Charles Babbage showed up. And he's like, oh, I could do whatever those humans are doing with some mechanical, gears and some metal and twist this thing and it operates this way and it can do the calculations for us. He started with something called a difference engine, which he later modified into a second version called the analytical engine, though it was never built. One of the talks he gave about this analytical engine, which was to sort of revolutionize this job that was being done with so much manual labor by humans. And this lady Ada Lovelace showed up to one of the presentations and wrote some notes back to the person, their sponsor, who sent her. And she wrote the first widely agreed upon computer program to calculate Bernoulli numbers, some interesting reoccurring numbers using this math, this machine, right? This machine. So programming, computing has happened for a long time, but it's always been this sort of like really specific, set of repeatable things that you can kind of do or have someone else do and then look at the results afterwards. But you can rely on it because it's just, it's straightforward. It's done reliably. And so this kind of aligns very well with how computers were built, is they were built with this idea of sequential processing in mind where just as they're going through these steps, these calculations, they're going through each step in order. There's no skipping steps. There's no backing up. There's no there's only moving one step forward at a time. And this is actually quite important. This comes up a lot when we try to figure out how a program is working or how a computer is working. Why did it do what it did? Well, just look at what it did before, and you can kind of walk back and see where it came from because it's just doing one step in order at a time. And let's take a look at a quick example here. Let's say that I have a goal, and my goal is to make a sandwich and order a book. And in the morning, I'm drinking my coffee, I'm making my plan for the day. And I want to give myself a list of things to do in order. I don't want to think, I just want to do. And so what I might do is I might make this list for myself, and I might say, okay, step one, I'm going to go to the bakery, and then I'm going to get some bread because that's where you get your fresh bread for my fresh sandwich I want to make. And then after that, maybe I'll swing by the butcher and I'll get some meat for my sandwich. And then maybe I'll make the sandwich now that I have the bread and the meat and maybe the other ingredients I already have. And then after that, I will search online for a new book and I'll order my book. And this sort of step-by-step list is meant to be done in order, one step at a time. I'm not going to go to the bakery and try to make a sandwich there. I'm going to go to the bakery, get my bread, and then go to the butcher and get some meat. And this is all that we talk about when we say something as big as sequential processing. It just means that computers, both in the 1600s and the more modern ones today, operate one line at a time in order very, very explicitly. Now, sometimes it can be confusing with how do we talk to computers, right? For humans, we have languages, but what defines a language? And I know that our humans, we're always adding and removing words. Computers, somewhat similarly, they've got a set of words they like to be spoken to or how they like to be spoken to. And what we call this is an instruction set. These are a set of commands or instructions that we can give to a microprocessor, which is a computer, that it can understand and execute. A very specific small set of things that it understands and knows what to do when it sees those words. These instructions tell them what to perform. They could be math, data manipulation, and input-output. And what do I mean by, all these? Math, I'm talking about just addition, subtraction, multiplication, division. There's some others in there that are cool, but largely it's these. With data manipulation, maybe you might be like adding or removing letters to names or words, or modifying numbers and attributes by increasing them or shrinking them. And then often computer programs are most interesting when they're interacting with users. So getting information from a user, like asking them about their name or their interests, or what they would rate a movie, and then telling them something like, hey, from this, I was able to calculate that your horoscope is whatever, right? But telling them something. So what can we actually do with this restricted set of instructions? So let me get to more programmer friendly, more realistic example instructions here. These happen in all the languages I can think of. We've got the ability to tell the computer to remember like a number or something, add numbers together, that's arithmetic, display this message often to a user in some form, and then multiply these things. And I came up with this really boring program, but let's take a look at it. I could tell you guys this, right? You understand English. Remember that x equals 2. Then add 2 to 3 and save the value as y. Multiply x by y and save the value as z, and then display the value z. Now, if you want, you could pause for a second and just think about what's going to happen here. If I gave this to someone in, you know, high school or perhaps even middle school, they would understand enough of this stuff. I'm sure a lot of elementary school as well. They understand enough of this stuff to tell me what the value is, tell me what the answer is. So you can pause and think about yourself, you being programmed by this English program. But I'll move on and I want to show you what this looks like when we're talking about actual programming languages, actual computer code. If I translate this to a language that I really like called Go, this is what it looks like when I want to tell a computer to do this program. I have some extra stuff around the top and the bottom, but generally it says remember x equals 2. This is me telling it that x equals 2. Add 2 to 3 and save the value as y. This is me adding 2 to 3 and then saving the value in y. And so on and so forth. Z equals x times y, and then display z. When we translate that to something like Python, it can often look a little bit simpler. This is why a lot of people like this language. I find that it's often easy to read, but it's a little bit harder to write as a first language. But x equals 2, y is 2 plus 3, display z, so on and so forth. And this is another pretty common modern language, C++. X equals 2, y equals 2 plus 3, so on and so forth, display z. And these are all example programs, but programs don't, the way that we speak in C++, Python, and Go, or write in C++, Python, and Go is much like a foreign language. But the real hard part that comes into programming is when we think like a computer, is how do we take this restricted set of instructions that we have and using just these build something like Netflix? How does Amazon make it so I can see this cool interface, click a button, and using simple stuff like this, make a new TV show up at my door? And that's what we're going to be learning throughout this class.